Yes, we are.
Nice.
So I think it's the first two.
I can't find it in the
It's it's in step 4 of 3.1. Do you see it there?
yeah.
Okay.
You guys got that right.
Four of 3.1. 4, 3.1. 3.1.1 or 3.1.2?
Oh, 3.1.1, and it's step 4 under the Excel instructions there.
Yeah, it says step 4, verify the requirements have been met.
Mine says there's currently no text in this page. You can search for this page title on other pages.
Wait, what?
What?
It's for the lesson for the individual preparations text reading thing.
Here, let me show you what I clicked on. Okay, I clicked on this.
Oh
No,
before that.
it's just above that where it says step 4. It's 3.1 step 4.
Got it. Okay, I'm like, when I clicked on that, it didn't go anywhere. So
Yeah, that. I was like. I wonder if that's supposed to be like a code that you can enter into Excel or something that'll reset all of the data to the default.
All right, so you guys put A and B.
Yes.
Save. The test statistics for a hypothesis test comparing two means with independent samples is
And that's actually just directly under
T. Two samples are independent if no new subject.
Would that be the t-score?
That's what I put.
yes.
So is this one knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2?
Correct.
Yeah.
Seems like I read that somewhere. Okay, for the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills in the dentist office. Okay, so are you guys copying and pasting this information into the spreadsheet like we did last time?
Yes.
Oh, dang it. Yes, it copied it on the second try. Remember how last time it was taking forever? Copy, paste.
Mm.
Okay, I've copied and pasted. Perform. What is the degrees of freedom? Degrees of freedom, is it 19? Wait, maybe I need to change my not equal to thing. Let me look at that. So it wants to be less than. So let me change that less than and see if that makes a difference. Nope, it still says 19.
Yeah, that's what I
No.
got.
Oh. You got 19.
Are you having yours be set at equal to or less than?
It's at less than.
What did you get?
37.996.
Mm.
And you just copy and pasted in there and then deleted what was in row 25 and 26.
Wait, was there something in row 25 and 26?
There was with the, there were already numbers there when I copy and pasted. And so with what I pasted, there were already numbers there in 25 and 26. So I just deleted those. And then changed my type of test to less than, and it gave me 19 on the degrees of freedom.
Are you doing it in two sample t-test?
No, I'm doing an impaired sample t-test. Maybe that's my problem. Okay.
Oh shoot, that's what I did too.
Perform. How do you know how to do that? How would I have known to choose that one?
Because
it's
we're
two
not
separate.
finding the differences between the t-tests. We're not finding the differences. We're finding. I mean, we are finding. One sec.
Okay, on this one I got 37.996 if we're doing it that way, but how would I know how to do that one?
Because we're not, because group 1 is independent from group 2. The bills in
offices.
Idaho aren't dependent on the bills in Rexburg.
Okay, not equal to, we're going to change that to less than 37.996.
or I guess, let me see, I think the best way to explain this would be we're not finding the differences as in minus, we're not subtracting the bills from in Idaho from the bills in Rexburg. We're just finding whether the bills in Rexburg are higher than the bills in Idaho, or the mean bills in Idaho or Rexburg are higher than the mean bills in Idaho. We're comparing them, not necessarily finding the difference.
Would the standard deviation be 208?
I was really quiet. Sorry, I missed that.
Would the standard deviation be 208?
208.875.
Mm-hmm.
It's actually going to be 206.637 because the standard deviation for variable 1 is the Idaho offices, and the question is asking for the standard deviation for Rexburg.
Which is variable 2.
So hold on. Rexburg is number 2. So number 2, 206.637. 206.637. What is the test statistic? How would I find that?
It's the t-score.
Yeah.
The negative 0.434?
Mm-hmm.
So,
And then the p-value is 0.33.
what is the p-value? 0.333. What is the correct decision based on this evidence?
You failed to reject.
That's what I got. Because the
0.10.
0.3 is higher than 0.1.
It's greater or
So the one that we're looking for is 0.1 and this is 0.3. So if it's low, then we reject the null. So since it's high, we're going to fail to reject.
Yes.
Okay. Suppose instead that you use alternative not equal to. All right, let's change that. What is the correct decision based on this evidence? We have sufficient. Oh, I hate these ones.
Yeah. Because is it sufficient if you like fail to reject and then insufficient if you reject or something like that? Is that how the wording goes?
It's sufficient if you reject the null. It's insufficient if you fail to reject the null.
Can you say that again?
It's sufficient evidence if you reject the null hypothesis. It's insufficient evidence if you fail to reject
if we fail to reject?
the null hypothesis. So this one should be, because we're looking for the alternative hypothesis. And this is just the way that I understand it. Hopefully I'm not wrong. But because we're looking for the alternative hypothesis, it should be that we have sufficient evidence that the dentist bills are the same.
So that it's C, the third one.
Right? Okay.
Wait, did I just write down your notes wrong? Because didn't you say sufficient evidence if we reject, insufficient if you fail to reject? So since we failed to reject, wouldn't it be insufficient?
Well, we're looking for the alternative hypothesis. We've already rejected the null.
Oh, I think that's why I keep getting them wrong. Is because I'm thinking of the null, and that's what I'm basing them off of, not the alternate. So it would be then the opposite, right?
Um, so if we were dealing with the null hypothesis, there would be sufficient evidence that the p-value being less than the level of significance would mean that we had enough evidence to reject the hypothesis. So, okay, now I'm confused.
Sorry.
Um, it's insufficient. Okay. We're good. We're good. We have insufficient evidence that the mean dentist bills between the two cities are different. I'm pretty sure.
Yeah. Okay.
Okay, I'm gonna try to rephrase it to make more sense. If the p-value is higher than the level of significance, it's insufficient. And if the p-value is less than the level of significance, it's sufficient. Hopefully that's correct. And another way, we could determine the correct decision would be if there was a 0 in the confidence interval. We could also say that whenever there's a 0 contained in the confidence interval, that the difference of the true means that there is no significant difference. Because that's something that we learned. So I think if you're ever questioning, just look at the confidence interval and see if there is a 0 in it. And if there is, then chances are it can't happen. That there's not enough evidence that it could be whatever the hypothesis is saying.
Okay.
Hopefully that's right.
So on this next one, are you still doing 2 sample t-test?
Yes.
Okay, I just copy and pasted it.
You got to be careful on this one though, because
There's not the same amount of samples.
no. So the information says let the sample mean for 1 be the times of that a student from Colorado cooks dinner, and then sample 2 population is the one from Utah. And if you look at the Excel sheet, they actually have it backwards, where variable 1 is from Utah, variable 2 is from Colorado.
Ew.
I knew they were going to do that to us eventually. I've been like looking out for it every single time.
That's annoying.
Yep, I wouldn't have noticed that. Dang it. Okay.
So here the null hypothesis is equal to, what is the appropriate alternative hypothesis?
It's just not equal to.
That's what I was wondering. Not equal to? What is the
I'm
test
just not looking for if
statistic?
they cook less than or more than. I'm just asking for different.
So is it 0.845? Number 13. You got a negative? You have your set at not equal to, right?
Mm-hmm. What's your confidence intervals?
Negative 2.214 and 5.147.
Okay. You have to flip variable 1 and variable 2. Because variable 2 on the Excel sheet, the one with less students is the ones from Colorado. And then the one with more students is the one from Utah. And the information says to put variable 1 as the students from Colorado.
It's -5. They come -5.147.
Is what -5?
Is that the lower confidence?
Oh gosh.
Okay. Wow. Okay, negative 0.967. For number 13.
No.
Is that what it says for T on yours?
That's what mine says for T. So variable 1, I just switched it to have 13, 14, 7, 20, that one, the shorter one.
And then variable 2 has 20. Oh, did you set it to not equal to? Or wait, I don't
Yes.
think that matters for the T.
It's
What's
not
your
equal
mean?
to.
Oh, I got something different.
Mean.
Do you have a mean for variable 1?
Yeah, 15.2.
And for variable 2?
16.667.
And then what's your standard deviation?
4.517 and 3.420.
And what's your sample size?
The N?
10 and 12.
That's weird. I know I messed up like not deleting stuff, and that's why I got some answers wrong.
This is what
'Cause,
mine
like,
looks like.
did you delete everything and then put
I
them back
deleted these
in?
ones that didn't have anything in them. And then over here, this is what I have.
Oh, you have negative 0.845 for
Right.
T.
Yeah, 13 is the t-score.
Yeah.
So what did I do wrong? Where did I get my other number? It's at not equal to, right?
Mm-hmm.
Yeah.
Okay, so negative 8.45. Wonder where I got
Maybe you
that
put
other
it in
number.
before you switched it. I don't know. But yeah, that's right.
Okay, 14 is 0.411.
Mm-hmm.
0.411. What decision do you make off of 0.05? Are we failing to reject? On 15, did you fail to reject?
Oh, yes.
Mm-hmm.
Determine a 95% confidence interval for 1 minus 2, an estimate for the difference between 1 and 2. Put your input. Okay, 95%, 1 and 2. Is this one already pre-calculated, or did you guys subtract them with the means?
I added them and then I divided them by 2.
You added the means and divided by 2?
Mm-hmm. Let's say you do it right, guys.
Dad, is that you with tape? Okay. Just don't want a kid going to town with the tape. Having to get done with a quiz and there's tape everywhere.
So then it should be 15.934 for 16.
Oh, I didn't get that.
For 16. That's what I got, but it's wrong.
Oh,
I got negative 1.466.
okay. Because how do you get it though? The margin of error. Is it the?
So, I want to experiment again, but I don't want to at the same time.
Well, I can put it in for mine when I turn mine in and then see if it's right. That way you don't have to
What?
waste your second one.
So for the margin of error, you don't add them 2 and then you divide it by 2? How do you do that?
I mean, the easiest way is just to subtract from the mean. But I guess if your mean's wrong.
So are you doing
But
the
then-
16.667 take away 15.200? So it'd be
No.
1.467. No?
Wait, sorry?
1.467.
I don't know where that comes from.
Because was it the mean from variable 1 minus the lower confidence level?
Okay.
Is that what it is?
No, the mean from. So
Or the standard, or okay,
the
I don't know.
information for question 6 says determine. So everything that we've done up until this point was the null hypothesis was that variable 1 mean equaled variable 2 mean. So now we're finding the difference because it's the variable 1 minus variable 2. So what I did was I put the information into the paired sample t-test to find the difference in the mean difference. That's how I got the 3.9 whatever. 3.694.
Okay, wait, you did it by how?
I put it into the paired sample t-test.
In the oh.
How did you get it?
Well,
I just subtracted 15.2, take away 16.667. So I guess it'd be negative 1.467. I don't even know what else.
see, that's why I didn't know how to do it. So I did the 15 minus the lower confidence level because I thought that's what you were saying before to do. But I guess that's from the other one.
So Josh, what did you put the first time and you got it wrong?
3.694.
Okay.
Oh. Okay, then how do we do it?
I'm going to put negative 1.467.
So this was what my thought was. My thought was that no, I'm being too critical of BYU's curriculum. Did I say anything?
Please.
I was like, maybe they've switched it back so that variable, the original Excel sheet, and they forgot to switch it. But that would be. Well, I'm assuming the error is mine and not the school's. Okay. So for this one, what we would do, where did my calculator go?
Are you still on 16 or are we moving on to 17?
I'm still on 16.
But 17 and
Is 17 negative 5.147?
yeah, they're just the upper and lower bounds. So then 18 would be 2.214.
2.214. Yep, that's what I got. Save. I'm just going to submit it and see.
Because you did the subtracting the variable 1 from variable 2, right? So 15 minus 16.
Yep, that's what I did.
Because that's
So
kind of what it looks like.
667 minus the 15.2. No. I said that backwards. It's the 15.2 minus the 16.667.
Okay,
And
so
then-
I got that one wrong and I got number 11 wrong.
For 16, did you put negative 1.467?
Yes.
And that was wrong. Okay.
Mm-hmm.
So then,
No, because that's just the mean.
Oh.
For
So
16,
here
we're
it
finding
says
the
it
margin
gives
of
you
error.
feedback. And on my feedback, it said the answer is SPSS is slightly lower than in Excel. So the answer given is the average between the two results. Your result should be close to the answer shown.
I don't know what.
I don't know what that
SPSS.
means.
well,
I've seen
SPSS is what he uses instead of Excel.
That's cheating. No wonder. That makes a lot of sense. Okay. So after going
So
back
the
and
answer given is the average
restructuring,
between the two.
Yeah, because I
So
guess
the,
it's different from all the way the formulas are set up and put in SPSS than it is in Excel.
um, so after redoing, the margin of error that I got was 3.681. I guess I should have just kept using. No, that doesn't.
and how did you get 3.681? Did you add
Oh,
the means?
it's variable 1 minus variable 2 minus the confidence interval.
Wait, so 15.2 minus 16.667 minus negative 5.147?
Yeah, but you have to do the variables in parentheses because that's got to come first.
Oh, maybe that's why I didn't get that.
I think I might let Amber submit this one.
Yeah, because I haven't submitted yet. So, yeah.
Just
Michelle
So
said
did
she
you?
got number 11 wrong.
number. Wait, you guys got number 11? I got number 11 right.
I got number 11 wrong as well.
What did
I
you
put
get for?
C. We have sufficient evidence that the mean dentist between the two cities are the same.
No. It's insufficient evidence that the cities are different. Same thing, but it's different.
So it's the second one.
So it's
Thanks
B.
for that.
Because it's science. Sorry. I got really confused after wording it all weirdly before.
Yeah, because you understood sufficient, not insufficient.
Yeah. So let me see if I can phrase it the way that I ended up realizing. It was if the p-value is greater than the level of significance, the evidence is insufficient. But if the p-value is less than the level of significance, the evidence is sufficient.
Less
And
than
then
insufficient.
from there, you're determining what the problem is asking for.
So it's the second one. Insufficient evidence.
So B.
Yeah.
Mhm.
Guys, what did you guys get for number 5?
B.
B.
Okay, so for 16, 3.68, is that what you're saying?
3.681.
3.681.
Or you
Because
have
that's
to
what Excel's telling me.
Um, oh, but you have a formula in your spreadsheet, right?
Yeah.
Okay. Because what my calculator says is 3.68 for 15.2 minus 16.667
Yeah.
minus the confidence, the negative 5.147. So it's probably just uh doesn't have all the numbers from Excel. So do you want me to put 3.681 and see if it
Yeah, I mean it should be close. I think it's actually like a range of numbers. The answer is a range of numbers, but like a small range.
yeah.
Like it'll take, you know.
Yeah, because I mean, if this is the right answer, I think even if I put 3.68, it should take it.
Okay. And the lower bound was negative 5.147.
Yep.
I put on 2.
2.214.
Okay. I'm gonna submit mine. Yeah, that was it. I got 100.
Nice.
Okay, so what did you say 16 was? 3.681.
I think she put
Yeah.
just 3.68.
Well, I did put 3.681.
Oh, okay. Cool. Boom. Hundo.
Okay, so I don't know how you got 3.681.
Okay. I wish I could just send you my Excel sheet.
I
So
know,
you just
right?
calculated it in Excel.
Yeah. So just if you look at my screen, if you look under where it says two sample t-test, there's a little tab section that I wrote in for margin of error, and the equation for that cell is it's just I have it set for um, variable 1 mean minus variable 2 mean minus, like in parentheses, minus the lowest confidence interval.
Okay.
Hmm.
It's right here.
That one's tricky.
I thought it was way more complicated than what it needed to be. That's why I got it wrong
So,
the first time.
so it's just by Excel, right? It's not like we can do it in our calculator.
You could. Wait, can you?
Margin of error?
Let's see. Yeah, you
Because I
could.
did it on my calculator. That's why I got 0.68. So I got 3.68.
How did you do it in your calculator?
Um, I did 15.2 minus 16.667
Mm-hmm.
minus parentheses negative 5.147 parentheses.
Trying to remember the formula for.
Uh,
Um, I don't think you could do this completely on your calculator. Like if you were to, you know, write out on a piece of paper an Excel sheet, I don't think you could because you would need to find the standard deviations. I don't know what you do with the standard deviations. Or the degrees of freedom for that matter, because the degrees of freedom say 16.562, but there are 22 samples in total.
all right, I put that formula in for margin of error, but I got 5.147. Is that,
That's the lowest confidence interval.
yeah. So I don't know why it's not doing the formula like yours did. Because that's E6 minus G6 in parentheses minus H23.
I mean, that's just how I have. So what I did when I wrote it in, I just did equals, like here, I'll even do it for this one, like variable 1 mean using the second set of numbers minus, oh, I gotta do parentheses. Did you do parentheses?
I did.
Wait, I didn't get that. So it equals.
So equals, yeah, so have the cell and then equals, and then click, or then do open parentheses,
Uh-huh.
and then click the mean for variable 1
Uh-huh.
minus the mean for variable 2,
Uh-huh.
and then close parentheses, and then minus the lower confidence interval.
Oh, that's why you have your mean and standard deviation for those. I do not have that. That's why it's just giving me the confidence interval.
Oh, gotcha. Yeah, that makes sense. Yeah. 0 minus 0 minus 5.147.
That
Classic.
makes sense. All right.
I got tired of putting all. Yeah, I put the formulas into those two and saved it, and so
Makes more sense.
so yeah, that just. And then for the sample, it's nice because I just did so like for the means, I just put average column A, and then for the other means, average column B, and then count, and then the function that counts the numbers in the column is equals count, and then so it's count column, and so I don't have to
Oh.
actually like type in the sample, even if there's a variable missing. It
Mhm.
doesn't count that as a variable. It just skips over it, and so it's like an exact count to the amount of variables. It gives me a proper sample size, which is I love Excel.
Well, if you don't have to use it, you people love it now.
I know, right?
I would hate to do this as a career though, like to be an accountant or something. Spend my life in Excel. That would be brutal.
I like Excel when it works for me.
Yeah.
Exactly.
Last week, nothing was going right for me in Excel. I was just getting so frustrated. But yeah, I would recommend just going through a fresh uh, Excel for the quantitative inference procedures, and then just typing in the equations for everything and then saving it. So that way, when you copy the data over, everything just is there for you. It makes everything a lot easier.
Yeah.
Instead of having to type everything in every time.
Hey, look, my margin of error now says 3.681. Go figure.
Nice.
Okay.
And then, like I said, the homework quiz for this week is pretty straightforward as well. It's not too bad, other than that, like one question that I missed, and that was only because I figured it out after the fact, which was the one about the standard deviations and the z-score. So, but I didn't tell you that because we're definitely live, and I would not say